Alright, apes, welcome back. We're going to wrap up the soil unit for real this time. This joke has nothing to do with today's lecture. I just can't stop thinking about it. Let's get right to it. We've already talked about the importance of topsoil, and I've hinted at some of the differences between topsoil and subsoil, Horizon A and Horizon B. And that's really what today's lecture is about. Remember from yesterday that one way to classify soils is to look at the balance of nutrients and analyze its pH. Today we're going to look at the method used by the United States Department of Agriculture, and they classify their soils based on sediment size. Remember that soil comes from weathered bedrock, and given enough time, a boulder can be broken down into pebbles and gravel. As the weathering and erosion processes continue, those pieces of gravel get worn down to form very fine pieces of sand. From there it gets even smaller, silt, and finally the smallest of sediment sizes, clay. When we examine the ratio of different sediment sizes in a topsoil, we are actually looking at what is called soil texture. To quantify soil texture, we must first separate the soil components into their different sizes. This is done using a device called a sifter. You are looking at the inside of the sifter container, and it's a series of compartments that have smaller and smaller screens as you reach the bottom. When you pour some soil into the top and shake it, the clay ends up down on the lowest compartment. This is just like in nature. As the topsoil gets weathered and beat up, the clay leaches or sifts down into the subsoil and collects there. You then take the compartments apart one by one. This is what one of the higher compartments looks like, and this represents larger pieces of sand. Notice that there are lots of different shapes and even different sizes that are mixed into this compartment. This is one of the middle compartments, and it represents the smaller pieces of sand. Notice that the pieces start to become more uniform and less textured in their appearance. This is the bottom compartment and our smallest sediment size, clay. Clay has an incredibly fine texture, and it is very soft and has the consistency of flour. In fact, in the Deep South, they sometimes replace flour in their baking. They use the red clay that is found in their subsoil. It's actually considered a treat when Grandma breaks out the red dirt to cook with. The next step is actually to measure each compartment and figure out what percentage of your soil was sand, the largest particle, silt, the medium particle, and clay, the smallest or finest particle. Once you have those values, you could ask an expert, like this guy, what they actually mean. Boy, he sure looks funny, amazing, awesome, and cool. He's probably busy though, so we're going to use instead the USDA's official soil triangle. At first glance, this may look a little intimidating, but I promise you, it's one of the easiest things that we will do all year. This is really just a graph with 3 axes of data instead of 2. Let's start with clay. You can see that clay is at the top of the triangle, and that says 100%. If you look over to the left side, you can see the percent of clay increases as it goes from 10 at the bottom all the way up to 100 at the apex of the triangle. Let me demonstrate what these lines look like on the triangle. That is 10% clay, 20, 30, 40, 50, 60, and so on, all the way up to 100% clay. Where would 0% clay be? Well, it's the axis line at the bottom, right there. Okay, let's do silt next. Silt is found in the lower right-hand corner, and you can see that that's where 100% silt occurs. And just like the other side, on the right hand, we see that percentage of silt increases as you move down the triangle. So here's where the silt lines actually occur. This is 10% silt, 20, 30, 40, 50, and so on, all the way up to 100% silt. Once again, 0 would be the opposite axis all the way on the other side. The triangle should really start to make sense now. Our last data point is sand, which can be found in the lower left-hand corner, and that represents 100% sand. So if we go all the way to the right-hand side, we see our line for 0 sand, 10, 20, as we work our way all the way up to the triangle to 100. Okay, at that point, that's a lot of lines, but you can see each direction of the triangle represents a different sediment size. Let's try an actual problem. You really only need 2 of the sediment sizes to solve because they always have to equal up to 100. So you can always get the third percentage by subtracting the other 2 from 100. I'm going to plot my percentages from largest particle size to smallest. So we begin with, in the upper left-hand corner, 58% sand. So I need to locate that on my soil triangle. And there it is. You can see that the numbers at the bottom of the triangle represent sand, and we see that it's slightly closer to 60 than to 50. Next, we are going to plot 28% silt. There it is as well. When we see them plotted together, both sand and silt, we now know what type of soil we have, according to the USDA. The intersection that occurs in sandy loam is our answer. Just for completeness, I'm going to go ahead and plot the 14% clay as well. We can double check our answer. We can see that the clay line intersects at the same spot, and therefore we know that we have correctly identified our soil as a sandy loam. So what is a loam, and what do all those different classifications on the triangle actually mean? Loam just essentially means a mixture of the 3 particles, and you see that loam in the middle is the ideal mixture for gardening and agriculture for most plants. As we move toward the different points of the triangle, we see that one of the particle sizes becomes dominant over the others. Well, you've probably learned way more about edaphology and pedology than you ever wanted to. And yes, those are the official names for the 2 major branches of soil science. And just for the record, I think that the soil triangle is much more accurate in terms of a personality test than using the astrological signs. Which type are you? Alright, soil is done. And I must confess, I don't understand any of these. I also don't drink coffee. Blech. Until next time, drop out.